All right, so we're looking at the labs for Module 5, and we are going to start with exercise 13. Again, this is exercise 13 that comes straight out of your lab manual, so go ahead and open up to page 71 so you can follow along with the information that's being presented here. So for lab 13, or I'm sorry, for exercise 13, we are specifically dealing with air pressure. So what is air pressure? Air pressure is, in essence, the force that is exerted by the atmosphere on any surface. We talked about air density and how air pressure is more intense the closer we are to Earth's surface. And again, that is due to the amount of gravity, or that is due to gravity, which is pulling down on the gases in the atmosphere, pulling it towards Earth, not only increasing the density, but increasing air pressure, again, close to Earth's surface. So the farther we get away from Earth's surface, the pressure is going to decrease. And so why is this important? Well, we can measure air pressure and changes in air pressure, meaning that we can have low pressure and high pressure systems, and there are interactions that will occur across space based on air pressure. And in order to measure this air pressure, we are going to be using another type of ISO line. Specifically, we're going to be looking at isobars, which specifically is looking at pressure gradients. And so it's really important to note that where we have areas of high pressure and areas of low pressure, air is always going to flow from a high pressure area towards a low pressure area. And so we measure air pressure, right, in isobar by millibars. So a high pressure area is going to have, 1,028 millibars, and a low pressure area might only have 1,000 millibars. So there's more pressure here, meaning that air is going to be flowing from the high pressure area to the low pressure area. And when we're looking at this type of pressure gradient, similar to how ISO lines work when we're looking at elevation changes or changes in temperature, the closer that the lines are towards one another, that means that we're having a steeper gradient. And so with a steeper gradient, steep pressure gradient, it means that the air is going to be moving faster over this area. So where our isobars are separated far apart, wind will occur because air pressure and air is moving from one location to another, but where they are separated far apart, air will be moving slowly, we'll be experiencing light winds, and where we have that steeper pressure gradient, that means that we're going to have strong winds. So high pressure to low pressure. Keeping in mind the pressure gradients, this may help you better understand or read pressure maps in the future, because I'm sure you've seen this before. If we're looking at air pressures, or we have a high pressure system and a low pressure system that exists over the United States, for example, but we can start to read these maps more effectively. So a ridge is going to be the high point. So 108, or I'm sorry, that's 1008 and 1008 millibars. So we know that this ridge that gets created between this low pressure system and this low pressure system, the high point is going to exist up here. The low point that will exist is going to be called a trough. And so you can see same thing, that in this area, based on the pressures surrounding this 1008 millibar pressure, this can be both a ridge and a peak, or I'm sorry, a ridge and a trough, depending on the air pressure that is surrounding it. So again, here we can see that we're going up in air pressure, and on the other side, we're going up in air pressure, creating a higher pressure point or a higher pressure area. And on the opposite side here, where we have a low pressure area, we can see that our air pressure is going down. And so the intervals that we're looking at, and this is going to be generally true for most pressure maps, is they're going to be represented in intervals of 4 millibars. So keep that in mind when we're looking at the gradients that are marked on our maps. But really what we're going to be doing today is taking a look at the station model. And that's basically an abbreviated way to take a look at not only air pressure, but also temperature, because as you can see, having all of these numbers on a map can be kind of clunky. So today we're going to be dealing with changing these air pressures into an easier to read system so that it fits easier on a map. So let's take a look at how to do those conversions. So when it comes to abbreviating air pressure, we have to remember that typically surface pressures are going to range from about 960 millibars to about 1050 millibars, low pressure and high pressure. So keeping that in mind, there are simple rules that we can use to help us to abbreviate these air pressures. So knowing that our air pressures generally range from 960 to 1050 millibars, we can use this initial trick. So if the first number is 4 or less, then we will be able to add a 10 in front of the complete number and put a decimal point before the last digit. So again, this is looking at a station model. And so if a station model is showing us this for air pressure, then we can convert it to adding a 10 because the first number here is less than 4 or is 4 or less, and then adding a decimal point. So on a station model, which again you can see in your lab manual, if we have a number of 196, then we can add a 10 in front of that number and add a decimal point before the last digit, converting this abbreviated pressure into its full pressure, which would be 1019.6 millibars. On the other hand, if the first number is 6 or more, then we're just going to add a 9 in front of the first number and put a decimal point before the last digit. So looking at our abbreviated pressure of 725, which you would find on a station model, we know that the 7 is 6 or greater. We're going to add that 9 in front of this and a decimal point before the last digit. So we would get an actual pressure reading of 972.5 millibars. So let's take a look at a few more examples. These are the examples that we looked at on the previous slide, so let's go ahead and practice with A. All right, so again, taking our cheat code into account, our first number is going to be less than or greater than 5 in essence. Clearly, 2 is less than 4, so what do we need to do? We are going to add a 10 in front of that number and a decimal point before the last digit. So you can see how I've more or less shown my work. We've added our 10, so our number becomes 10 to 90. And now we have to add our decimal point between the last two digits, so our total air pressure is going to be 1029 millibars. So using that same trick, go ahead and see if you can figure out B. I'll walk you through that one, and then you can really test yourself on C and D. So B is our first number greater than or less than the number 5. 870, our first number is greater than 5, so it is 6 or more. We are going to add a 9 in front of that number and put a decimal point before the last two digits. So the actual millibar reading, that would not be the abbreviated version, would look like 987.0 millibars. So go ahead and test yourself for C and D, and you can see the examples on my next slide. So if you don't have the answers yet, go ahead and pause the video now, otherwise the answers are going to be spoiled for you. All right, how did you do? And now that you see how to go from the station model, right, the abbreviated version, back to the full millibar reading, let's see if you can decode it. So practice decoding, aka going backwards. Let's see if you can convert these full millibar readings into the station model, the abbreviated model. Again, take into account these first these quick tips. To go ahead and pause the video if you need a minute, otherwise the answers are going to be shown for you. All right, working backwards on number A, 10,423. Clearly we have added a 10. Our initial number was 4 or less. So what we're gonna have to do in essence to work backwards is to delete this 10, remove this decimal point, and we are going to be left with the abbreviated station model of 423. Same thing with this 9. delete the 9. We know that this is 6 or more, so our station model, the abbreviated pressure model, is going to be just 633. So I hope that worked out for you. So for Labs 9, the practice and the graded lab, you're going to be asked to decode the station model dealing with the pressure points, the pressure gradients, as well as using your knowledge of ISO lines, specifically these ISO bars, to evaluate the accuracy of the ISO bars displayed on a map. So keep in mind our high and low pressure systems. Again, for future knowledge, the gradients and the intervals when trying to analyze a map, and look at your map options very carefully, looking specifically at the intervals and the gradients and where the high and low pressure systems exist in order to answer the questions correctly. Good luck. Otherwise, let me know if there are any questions.